it will be linked by using a connection, a line that will be transmitted, the data will be transmitted through that particular line. So in this, how it will work is the primary device and there are multiple secondary devices. So we will be considering all this as single transmission line. So there will be exchange of data through only primary device. So the primary device is the main thing that will exchange the data between one device to other device. So the destination device may be a secondary device which the primary device will be selecting. So for example, if you take a primary device, so that will be having the control over the communication link throughout the topology which is being constructed. So the secondary devices will follow the instructions of the primary device. So whatever instructions is given by primary device, it will be followed by the secondary device and it will be done by the secondary device. So the primary device will determine which device is allowed to use the communication channel. So we have a communication channel through which the data is being transmitted. So the primary device will select or will allow which secondary device should use that particular communication channel. So here the primary device is known as session or initiator. If the primary device wants to receive the data from the secondary device, what it will do is it will ask the secondary device the permission, or it will ask the secondary device that they have anything to send. So this process is known as polling. So if the primary device wants to send some data to the secondary device, then it tells the target or secondary to get ready to receive the data. This process is known as selecting. So here the polling is nothing but the primary device wants to receive some data from the secondary device, then it will ask the secondary device that they have anything to send. That is known as polling. Similarly, the selecting is also like primary device only wants to send some data. So there it is like it wants to receive the data. Here it needs to send some data to the secondary device. That particular device, it will select, the primary device will select and it will ask that secondary device whether it is ready to receive that particular data. So this is known as selecting. So in select mode, we will be using the primary device to send some data, right? So when the primary device wants to send some data, then it will alert the secondary device for the upcoming transmission by transmitting a select frame. So it is denoted by SCL. So one field of the frame will include this address of the intended secondary service. So this device address will be given in the frame also. So we have different sections in frames, right? So in that the secondary device address will be stored. So when the primary device is sending data. So when the secondary device receives the select frame, it sends an acknowledgement. So it will be sending the acknowledgement that indicates that the secondary device is ready for the another frame to receive, right? So it means secondary device is ready to accept the data, then the primary device will send two or more data frames to the intended, that is selected by the primary device, right? So primary device itself will select the secondary device, the target device, to send the data from primary device to secondary device. So once the data is being transmitted, the secondary device should send acknowledgement each time whenever it receives a data from the primary device. So if you see here the example, we have a primary device and we have different secondary devices that are denoted as A, B and C, right? So here the primary device is selected the target as secondary B. That device to be the receiver end. So here the primary device will give the data, will share the this select frame. This will share the frame to the secondary B device. So when it receives, it should send the acknowledgement to the primary device. So again, after receiving the acknowledgement, the primary device will know that the secondary device is ready to receive the data. So again, the primary device will send the data to the receiver side, that is secondary device. So again, it will send the acknowledgement. So here, each time whenever it receives a frame, it will give the acknowledgement to the primary device. So coming to poll, so this mode is used when the primary device wants to receive some data from the secondary device. So here poll means it wants to receive some data from other devices. So when a primary device wants to receive the data, it will ask each particular device, it will ask each device which is present in the topology whether it has anything to send. So first it will ask the first secondary device. If it responds with negative acknowledgements, negative acknowledgement, then that it means it has nothing to send. So again it will approach to the secondary device. So if it responds with acknowledgements, that it does means it has data to send. So the secondary device can send more than one frame, one after other, or sometimes it may be required to send acknowledgement before sending each one, depending on the type of the protocol that is being used by the secondary device. So if you see in this example, we have a primary device and we have three devices, right? So as I told in poll, first it wants to receive the data. The main thing is primary devices need to receive the data from any of the secondary devices. So here the poll will request to the secondary devices, each devices. So if it gets negative acknowledgement, that it means it doesn't have any data to send. So it doesn't have any data to receive in primary device side. So when it gives request to the secondary B, that is this device, so if it is having acknowledgement, so it should share the data. So that after receiving the data in primary device, so it will send the acknowledgement to the secondary device. So if we check with other secondary device, so here you can see negative acknowledgement is being given. So if it is negative acknowledgement, there is no data that should be received by primary device. There is no data to send from secondary device C. So this is about poll and select in line. The next one is flow control. So flow control, so this function is like it is a set of procedures that will say the sender how much data it should transmit before the data is being overwhelmed by the receiver. So here the receiving device has limited speed and limited memory to store the data. The receiving device must be able to inform the sending device to stop the transmission temporarily before the limits is reached. So here we have two devices, right? One is sender, one is receiver. So if the receiver need to receive the data and sender needs to transmit the data, right? It should share the data from sender to receiver using transmission medium, right? So here when the data is being transmitted, the receiver end has some limitations. So that is it has a limited speed, limited memory to store the data. So if it is able to inform the sending device to stop the transmission temporarily. So when it is filled, when it is reached that limit, it should send the transmitting or the transmission to stop temporarily the transmission from the sender side, right? Then only it doesn't overflow. So because of this limited speed and limited memory, it requires a buffer. So that will block. Buffer is like a block of memory that will store the information that is being processed. Already processed data will be stored in a buffer. So a buffer is nothing but it is a block of memory for storing the information. So here we have two methods to control the flow of data. One is stop and wait and other is sliding window. Coming to stop and wait, in stop and wait, the sender will wait for an acknowledgement after every frame it sends. So if the sender is sending a message or the data from the receiver, and it should definitely require an acknowledgement that the data is received correctly or the data is stored. So when an acknowledgement is received, then only next frame is sent. So this process will follow alternatively sending and waiting of a frame continuously until that uh, sender transmits end of transmission frame. So that is end of transmission frame is like end of that data which should be transmitted from sender to receiver end. So what is the advantage of this stop and wait is this method is very simple as each frame is checked. So after checking only it will be giving the acknowledgement before the next frame is sent, right? So what is the disadvantage? It is inefficient, right? So for each frame we need to wait until it travel across all the way to the receiver, and the acknowledgement should travel all the way before the next frame is being sent. So here it is very inefficient, and each frame sent and received uses the entire time to need. So it is time taking to traverse that link, right? So these are the disadvantages in stop and wait. So other one is sliding window. So the sliding window is also a method to control the flow of data in which a sender can transmit the several frames before getting an acknowledgement. So in sliding window, it can transmit multiple frames one after the other, due to which it will show the capacity of the communication channel that can be utilized efficiently. So here a single acknowledgement will be getting through to multiple frames, right? So in stop and wait, for each frame we will be getting an acknowledgement. Here we will be getting a single acknowledgement for multiple frames. In sliding window, we will refer an imaginary boxes at both the sender and receiver end. So this window can hold the frames at either end, and it will provide the upper limit on the number of frames that can be transmitted before the acknowledgement. So here the frames can be acknowledged even when the window is not completely filled. So if you take this, the window has specific size in which they are numbered as modulo n. So which means here the number can be taken from 0 to n minus 1. So for example, if we take in the number 8, so how many number of frames will be there? That will be 0 to 7, right? So we will be having different types of combinations if we take 2 power 8, right? So what will be the size of the window if we are representing as n minus 1 is the maximum n minus frames can be sent before acknowledgement. So if you see the sender window here, at the beginning of the transmission, the sender window will contain n minus frames. So here n minus frames will have, and when they are sent out, the left boundary moves inward shrinking. So you can see the left boundary will move inward shrinking, means it will be closing, coming closer in the left side. So the size of the window will change. So if we are taking window as W, if we have three frames that are sent out, so the number of frames left out in the sender will be W minus 3. So here the acknowledgement will arrive. Then the sender window will expand to the number which will be equal to the number of frames acknowledged by the acknowledgement. So whenever we are in sender side, whenever we are sending this data out, this window will be shrinking inwards. That means inside it will be decreasing the size of the window. So whenever the acknowledgement is coming from the receiver side, so that the window will expand, the sender window will expand based on the acknowledgement received by the receiver side. So here in receiver window also, in the beginning of transmission, the receiver window will not contain n frames, but it contains spaces for frames, that is n minus spaces. So when the new frame arrives, the size of the window will shrinks. So the receiver window does not represent the number of frames received, but it will represent the number of frames that can be received before an acknowledgement is sent. So it will assume how many number of frames can be received before sending an acknowledgement to the sender. So if you take this receiver side, so you can see here, this is the wall to the right side when a frame is received. So when the frame is received, it will enlarge the window, and this is the direction where it is enlarging. So when the before getting acknowledgement, it will be the receiver window. So the walls will move to the right side when an acknowledgement is being sent to the sender side. So this is about sliding window in sender window and receiver window. Next thing is error control. So error control, we all know we need to detect an error and we need to correct an error, right? So that is error correction and detection. So error control is also a technique where we detect the error and we will be retransmitting the data here. So there are different types of categories in error control. If you see here, one is stop and wait, other is sliding window. In sliding window, we have two more things. One is go back and selective reject. So when we see stop and wait, so this technique is used to retransmit the data in case of damaged or lost frames. So if the data is being damaged or lost when the sender is sending the data from sender to receiver, so stop and wait ARQ technique is used to retransmit the data. So how this technique will work? It work on a principle that the sender will not transmit the next frame until it receives the acknowledgement of the last transmitted frame. So here it works in the principle called it will not transmit any next frame until it receives the acknowledgement. So it should receive the acknowledgement until it transmits the last transmitted frame. So if it does not receive acknowledgement, it will not transmit the next frame. It will stop there itself. So we have four features that are required for the retransmission. So what are the four features? First, we need to take the sending device that should keep a copy of last transmitted frame until the acknowledgement is received. So by keeping this copy, that this will allows the sender to retransmit the data if the frame is not received correctly or not. Both the data frames with and the acknowledgement frames are numbered actively or alternatively by using zeros and ones so that they can be identified individually. Suppose data 1 frame acknowledges the data 0 frame, that means that the data 0 frame has been arrived correctly and it should expect to receive data one frame. So if there is any error in the last transmitted frame, so the receiver sends the negative acknowledgement frame which is not numbered. So here the negative acknowledgement frame will not be numbered when the error is occurred in the last transmitted frame. So on receiving the negative acknowledgement frame, sender will retransmit the data to the receiver side. So it works with the timer. So if the acknowledgement is not received within the allotted time, then the sender assumes that the frame is lost during the transmission, and then again the sender will retransmit that particular frame again to the receiver end. So this is stop and wait ARQ. So we have two more possibilities of retransmission. So when will we retransmit the data? If the data is lost or if the data is being damaged, right? So when the receiver will receive a damaged frame, that is the frame contains an error. We all know the error may be changed. So the data may be different. So in error, we can check which position it is changed and where it is changed, right? So then it will return negative acknowledgement frame. So if the data contains error, it will give negative acknowledgement frame. So they have taken an example called data zero frame is sent and the receiver will send the acknowledgement as one frame. Means the data zero has arrived correctly and it transmits the data one frame. So here they have taken the data as 0. It will represent the data as 0, and the acknowledgement which is received from the receiver side to the sender, that will be represented as 1. So the sender transmits the next frame. So the next frame is represented as 1. So if it is reached correctly without any damage, so the receiver end it should send an acknowledgement, so that is denoted with 0 here. So whenever the sender transmits the next frame the data 0, the receiver should reports an error and returns the negative acknowledgement if there is any damage in the data frame that is sent in a transmission medium. So then it can retransmit the data 0 frame. So this is how the damaged frame will retransmit the data. So when the data is lost or we have lost frames, what is the possibility that we can retransmit the data is, here the sender is equipped with the timer. So here we have a timer here and it will starts when the frame is transmitted. Sometimes the frame has not arrived at the receiving end, so that it can be acknowledged neither positively or negatively. Sometimes we do not know whether the data is being transmitted correctly to the receiver end or not, right? So it may be positive or it may be negative. The sender will wait until acknowledgement will come within that particular time. So once the timer goes off, so it will again retransmit the last transmitted frame. So this possibility is there in lost frame for retransmission. So here we have sliding window, right? So yes, this is used for continuous transmission error control. So here we have three features used for retransmission. So we have three cases here. First one is the sender will keeps the copies of all the transmitted frames. Whatever frames the sender is sending, everything it will be copied and they have been acknowledged. Suppose if we are taking 0 to 4 frames, that is 0, 1, 2, 3, 4. All these frames are being transmitted and the last acknowledgement was for frame 2. If we think the sender has to keep all the copies of frames 3, 4 until they receive correctly. So until all everything 0 to 4 it should receive correctly all the data frames. So the receiver can send either negative acknowledgement or acknowledgement depending on the conditions. So if it is negative acknowledgement frame, so the it will say that the sender will have the data that have received damage. So if we have negative acknowledgement, that means the data is received as damaged frames. So since the sliding window is a continuous transmission mechanism, both acknowledgement and negative acknowledgement must be numbered for their identification in that particular frame. So if the acknowledgement frame consists of a number that represents the next frame, which the receiver will expect to receive. So the negative acknowledgement frame consists of a number that will represent the damaged frame. So here the acknowledgement will have the next frame number and negative acknowledgement will have damaged frame. So the sliding window acknowledgement is equipped with timer. So it is also having timer to handle the lost acknowledgements. Who is Anurag? So this is the sliding window that is present in error control, right? So we will be discussing the other two parts under error control in tomorrow's class. Thank you.